Okay, I'm just going to finish this project off. So I said the last time I did this, or I've said at some point, that I realized that the 4001 could be used to generate the clock signal, and I don't need the 555. The 555 little adapter thing I've actually misplaced temporarily, so it's not actually going to work at the moment. So we're going to fix it up so that it does work. Just going to make sure I've actually got a 9-volt battery sitting. I assume so. Well, yeah, here we have everything. This is a very, very rough and ready video, so I don't know how it's going to go. But anyway, so here in trusty integrated circuit hobbyist handbook, it has the layout for this. So it's I'm going to use this one here because it's very similar to what I did with the 4049, though I don't know if I ever actually went through how you do this. But anyway, so this here says it's going to make a tone for a speaker, an 8-ohm speaker at 1 kilohertz, which is amply fast enough for me, with a 100k resistor going there, and you just need a 0.01 or 104 capacitor. So I've got a 104. There's like a little tiny rubbishy one. And I also have them as I had some of these green cap ones too. I thought I might try those because they're a bit easier to work with. I don't know if I have any 104s though. I mean, I must have. There's an awful lot in here. Do they come in 104s? They do. Well, we won't bother with this. It's just that that's such a tiny little thing. And I really want to use these ones because they're easier to stick in the... There's the 103 ones right there. Who cares? Doesn't really matter. I don't know. It doesn't give you a formula to work out the frequency of oscillation. Anyway, I don't have any 100Ks directly available because I haven't actually bothered checking. So I'm just going to use this little bag which has 82K written on the outside. So I'm going to assume that's fine. So this will either make it go a bit faster or a bit slower, probably a bit slower. So that's fine. I don't really mind. It's still amply fast enough. So let's just make this up and get it to work. So these are the free gates over here. So we'll just use those ones. I don't know if I've got one spare one over here as well. Excuse me. Which we may have to use to buffer things. But we'll take this one out. These wires out for this second. So how am I going to do this? Because I kind of want the picture. Gosh, my throat doesn't feel good. I think I'm out of water. No, I'm not. Oh, I am. Hold on. It's still that kind of night, and I ate some nuts. So I don't know if I've ever mentioned it on this channel, but when I eat nuts, I tend to cough, and I was supposed to stop eating nuts late at night so that I wouldn't cough. Is there any point for me having it right here? Yeah, there is a point. It's going to be right there, and it's fine. Okay, so I've removed one. We'll do this part first. So I'm going to just tie those two together, which means I need those really, really small. So basically, you're just turning them into inverters. Where are the little tiny ones? So that's the neat little thing. So I'm just going to put this little tiny green one. I just have to double check. So we're on this side, 2, 2. Alright. That's... Oops, oh my goodness, these things. Where is it? I seem to have misplaced my normal sized pliers. So we're going to have to use the giant size ones. That's a bit disconcerting. In you go. Is this going to make it any easier? It is. There you go, it's gone in. Alright, so we've linked those two inputs together, and then we'll put another one in because we're going to link the other two. I think on this one here you can actually use the extra one so you can turn on and off the oscillation. Well, basically because if this is on, then the output's always going to be low, so it won't oscillate. So that's the nice thing about using this over using an inverter, other than it was slightly tricky. Alright, to do that, so we've got this 1K, 100K is coming out and it's going straight back in. So I'm just going to, I always like it's hard to, I always find it a little bit hard to turn this picture here into a board layout. But I think I'm getting better. I've done this one a couple of times, so I'm just going to cut the legs a bit short because they are a bit long. All right, so that comes out, and then we can take these wires out. I don't know how good this is to watch when you can't really see what I'm doing. All right, well I'm just going to bring it up real close. All right, and I'm going to take this one and I'm just going to cross it over like that. So that's my kind of almost 100k resistor, and it's going in and it's going straight back to there. And so from this point here, I also want the capacitor to go to the output of that one. So that's this. I can just jump across like this. Alright, so I hope that works. So that's my circuit so far. Does that look right? I don't know. Can you even see what I'm doing? That bit there. So that's the output of the other, that's the output of this one. That's the capacitor there. That's going over to this output here, which is, I think I've done that wrong. No, it's going to the out, that's what I always get this wrong. It's going to the input here. So these are all linked up. So that makes sense. Okay. And we've got this little connection here. So the output of here is actually going into the, this is going to be hard to wire up, isn't it? I've used up all the space. I think I should have put the capacitor in last. I think I need a shorter one than that, but a longer one than the green one, which is this one here. So I think this is going to work. Alright, so that one, the little brown wire, is this connection here from the output of this one into the input of this one. So it's going from the output, which is that pin. I'm going to use another resistor. This is the output pin. It's going through here, across into the input pins. So either of those would be fine. And the output of that one is being connected back to the resistor. It doesn't look like it, but it's going through those wires there. So there's they're linked up. Those two lines are linked together. So I think I've got that fine. So now the only thing left, and this is pretty much the whole video, because I don't know if it's going to work, and hopefully it will work because then I don't have to do any like thinking. The only thing that might happen is I might have to buffer the output, so I'll just have to run the output into, like I could even do that straight away, like it wouldn't make any difference at all, but it's just going into another CMOS input, so I don't think I have to. So I could buffer, because there's one more NOR gate left over on this IC over there, so if I have to buffer the output, I'll just stick it into that one. But we will not buffer it, we will just take it straight off there. So this is my clock, this is now my clock thing. And I do have, so I think I'll put the testing, my mock-up controller up away from here, but I think I can reach it if I have to. But I'm pretty sure this is actually the working controller. So we'll plug this in to test it to see if it actually works. Because I don't think I actually did a demonstration with a real controller. The last thing I have to do though is just check out which is the actual input, the actual pin number for the clock on the 4017. So there's the 4017. The clock is pin number 14. One day I will actually know all of these off by heart, and I will never have to do this again. I'm just actually not sure which is the 4017 IC. It's this one here, right? So clock pin number 14 is right there. So there we go. That's it. That should all work. That's my final model. And is it going to work? Where did I put the? This is the connector. And we need a battery. I just had these batteries. Like I actually just put them up. They're right here. All right. Okay, so plugging it in, turning it on, no lights come on. Well, that's something, but that doesn't mean anything. Let's plug in the controller, and then we can say we've finished this. And I'm actually going to solder this up at some point. But it's nice not to have to use an extra IC. And this, I'm going to take this blue wire out, like it seriously, because it's not attached to anything. It doesn't need to be there. It's just going to cause problems. So we'll just turn it on, and it doesn't. Wait, well, we got a light, so that one works. Well, it's up and down. Oh, this is terrible. I don't want this to happen. Alright, we'll have to get my testing thing. Alright, here it is. Still in reasonably good shape. So we'll take that one out. What have I done? Maybe the clock rate just doesn't work. Well, I'm going to have to, aren't I? I'm going to have to take this output here and run it into a test pin. Well, what is this one testing? It's testing something. Wait, that was the output from one of the four. That should be flashing, shouldn't it? Yes. So obviously we've done something slightly wrong here, which is like terribly, terribly sad. So I'm just going to take that one off for a second, and I'm going to put, ooh, look at that, it's doing some funny thing. Well, now the light comes on, and now it's flashing. Well, that's disconcerting, and it's flashing at a pretty good rate. Now it's flashing without my help. That's freaky. What is it actually? Hold on, let's just plug this in. Now it's going to get hard to work this out. Alright, so the light comes on, and none of the buttons work, except for that particular one, which is disheartening. So one of these has fallen out, which will be that will be the down one. Alright, so up and down should work. Alright, so up and down do work. That's not what we want. They don't matter. So I have to plug this back in. Hold on, this cannot be right. Alright. I didn't really want to do this. I just wanted... Oh, I've done this completely wrong. I've been looking at this IC upside down. Right. Clock pin number 14 is actually on the other side. So that's exactly why it's not working. So there we go. They should just make ICs perfectly symmetrical around both sides, so you can rotate them around and you never have any problems. Hobbyist ICs should be exactly like that. They should be just twice as long, but you just rotate them around, and then you wouldn't have any problems. So let's just see if it works. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. Well, it seems to work, so that's good. It works. Yay, we made an oscillator with a NOR gate. Never done that before. Done it with an AND gate, done it with an inverter. So there's always something new to do, even though it's exactly the same as it is with the other two cases. So yes, if you're really stuck, I'm just going to show that one last time. Though this book doesn't have a formula for working out. I really wanted to go through and decode this kind of oscillator and just try and explain and work out exactly why it works. Like, why does this thing oscillate? Like this one down here, if you use a 100k and a 1 million ohm, this one's got 3. That's interesting. I've always done it with I thought this was a bit strange, because I've always done it with 2 resistors and a capacitor. So what does that do? Why does that work? So yes, I'm really going to have to think this out and then do a video about why these two things work. So, but anyway, you can do it. It does work. An oscillator with just 1 resistor, 1 capacitor, and 2 NOR gates. So let's just turn this on, finish this thing off, and then we can never have to speak of it again, except later on when we do other projects. Does it work? So it doesn't really work the way... Oh no, this is the broken one. I just plugged in the broken one. So that's the broken one. You can tell it's the broken one because the cables are tied together, because it was the one I'd never used. So maybe it was broken. It wasn't broken. I was going to say maybe it was broken when I bought it, but in fact I did try them both out on a fake Megadrive at some point. So this is the non-faulty one, I hope. So A B, C, start, left, right, up, down. So it all works, and you can hold the things down and do all the bits and pieces that you have to do. So that's nice. Look at that, it's nice and responsive, and these buttons don't do anything at all. So interesting. We'll have to come back to why that is. So just a reminder, I think how they work is if you change the select from high to low or something at a certain time, the buttons you read in are the other set and not the first set or something like that. So it's all to do with the timing, and the timing is roughly around the 60, to do with the 50 or 60 times a second that you're updating the screen. So it should be like, I don't know, if you do it faster than 100 Hertz or something, I thought it would cause problems, but I'll have to actually sit down and think about that. But for now, it's all done. It's over. It's finished. Bye. The next video, I think, well, the next video is going to be a kit, like an educational kit thing. But after that, we're going to do, I don't know where I put it, a little game thing with an Arduino, which is this thing here. So this will be something to look forward to. So this is, I'm just using a Nano. And the trick with this little game is we're then going to build it out of logic ICs. So we're going to do it first with Arduino code, and then we're going to do it with logic ICs. So this may be a little bit more involved than I think, or it might be quite straightforward and fun, but we'll find out soon. So thanks for watching, and bye.